Hi, Andrew McLaren. This is MTR1201 Millie's Flying Fish. This is the sensor hardware and implementation assessment. So as we can see now, that out of the way, the motor and the sensor are wired. The sensor is wired as per the tutorial with the signal, power and earth. I did have one minor issue with getting the sensor to work. Basically on my board there are two grounds and I thought I could use the two separate grounds, one each for the motor and that, but it turned out that it didn't work if you had them wired to separate grounds. So only changes from the previous two videos is that I had to make a jump and solder the ground so I could run both the motor and the sensor off the same ground. But yeah, so that's all in and appears to be working properly. So I will start and upload the sensor program. So as we can see, this will be the raw and calibrated data. So just sitting statically, zoom in, sitting statically, everything looks reasonable. And then obviously if we move it manually, the data does vary, so it appears to be working correctly. So for the next one with the converted data, I've done just a second program to demonstrate the converted data. And basically we have defined the scales based on the product information sheet for the IMU. Gone for the highest sensitivity factors, or sorry, I guess it's the lowest sensitivity factors value, because obviously this is not going to be doing anything too crazy. If we need to amend that based on it not being stable in the future, we can change that. But I'll upload that one. I've included a few motor movements in this one as well, but yeah, it's probably going to be a bit hard to demonstrate in the airflow because of the cable setup. But if I go back to the serial monitor, and we should be able to see the converted values. Obviously they're going a bit slower because it's not running constantly. I've just got them in between the motor movements. I'll manually give that a move, and we should be able to see those values changing. Just moving it sort of 90 degrees. So appears to be going pretty well. Obviously the next steps, zoom out, the next steps in this will be to calculate and remove the bias from the sensor readings, and then to integrate those readings over time to obtain an angular position for the body of the fish. And then we will relate that to the servo motor angle and then map the position against the servo motor angle so that it knows where it needs to move. Thank you.